Welcome, welcome. It is so good to see you here today. We've got more people joining us. We'll get everybody settled in and then we'll get started soon. Hello, hello. My name's Lori. I think I know a lot of these people joining us today. It's great. Oh yeah, I know many of these names. It's so good to see all of you. Awesome. We're getting a great group today. So for those of you who may not know me, my name is Lori. I'm a PD specialist here at CodeHS, and I am very excited to be with all of you today with the amazing workshop that we've got coming your way. First of all, Python happens to be one of my favorite languages. I have a few, but I love Python. There's just something amazing about that, and definitely helped me engage a lot of kids in programming. So I'm very excited about that, but I'm even more excited that we have Kent Pendleton with us, one of our amazing teacher trainers. I love his sessions. So I'm super excited to bring Kent here for all of us today. All right, we'll get started in a moment. And excellent. I can tell that you're excited too, because I see those introductions coming into chat. So go ahead and take a minute to introduce yourself in chat. And in fact, I'll just go ahead and there we go. Switch to the next slide for us. If you'd like to tell us a little bit about yourself in chat, feel free. We would love to hear more about you. And we'd love to know where you're coming to us from today. That would be perfect, please. Love to see where our CodeHS educators are at. Welcome, welcome, welcome. We've been getting a very international audience lately, so I'm super excited to see y'all coming back again. Hello. Awesome. All right. And tell us a little bit about what your teaching experience is. Have you had experience teaching Python? Have you used CodeHS before? It's totally okay if you have not taught with CodeHS. And if you don't have experience with Python, no worries at all about that. Some of the things that Kent will be going over might feel a little bit overwhelming if you don't have experience with it, but no worries. Python is a language that is pretty accessible. So you're going to learn a ton from Kent. I often say I wish I could be in his classroom with his students. I would love to experience that. Welcome, everybody. All right, we've got APCSP, APCSA, and Python. Perfect. Oh, cool. Wait a minute. What is that new class for next year? Everything just moved on me really fast. Did I see something about quantum?
A new class in quantum computing, which I'm not personally teaching it. I'm holding space for a professor to teach it, but I'm geeked beyond belief about this new class.
Oh, I am so excited about that. I would love to hear more about how that's going. So keep us posted. That is so cool. Awesome. That is so cool. You just saw us all have a little nerd out moment there with that one. Excellent. Middle school computer science. Love it. Coding and web development. That's so cool. I was primarily a high school teacher, but I was very lucky because I was at the district level. And so I got to go into middle school classrooms. I did Girls Who Code, tech clubs with middle school kids. And Python was one of my favorite things to bring to them. Cool, cool, cool. ESL teacher, hello. You're going to love Python. Oh, excellent. Integrated math. We got a math teacher with us. Little experience with Python, but never formally taught. Well, let me tell you something. I was never formally taught either. Many of us were not formally taught any of that. I was actually an English teacher in a former life and a librarian. And the reason I know Python is because of CodeHS. Cool. Awesome, everybody. Thank you so much. Keep throwing those in. Love to see where you're all from. I said yesterday at our workshop that I was going to put together a map so we can see where our educators are at. And we'll get that out on social media so all of you can see it. All right, everybody. Let's go ahead and keep jumping in. I think our numbers have started to settle down. So our first link of our session today is for the slides. You may want to grab these slides if you're in a place where you can grab them. There's going to be some links here, but we'll show you some other places you can get to those links as well. And if you can't grab the slides right now, no worries, because I will make sure you get those afterwards. They'll be in the workshop section as well. But let's see, you can go ahead and grab those slides from chat. Don just threw the link into chat, codehs.com/python-exp-slides, or scan our QR code. You can grab that. I'll leave that up for just a moment. I'm going to see who else I've been missing out on. Hey, Wendy, welcome back. Hi, Nelson. Awesome, everybody. Excellent. Welcome, welcome. Okay. Now let's go ahead and check out what we've got next. Okay. So this is our question parking lot. Many of you have been with us at other workshops, so you're really familiar with what this is, but you will definitely want to pull up the question parking lot, codehs.com/python-exp-questions. This is where we would love it if you could throw your questions. We have a good number of people here, and we just don't want to miss anything. And we'd love to encourage conversation and chat and things like that. So if you've got questions, please toss them over to the question parking lot. Somebody behind the scenes is going to go ahead and get those answered for us. And if we can't answer them today, we want to make sure we can get back to you with those answers. So please add your questions there. You can also scan that QR code. I'm going to leave this here for a moment. I'm just going to say, introduce our team members who are on with us as well. We also have Don with us. Don is on the PD team. Don's waving right now. And we have MR, who is also a PD specialist, and she's waving. So they are going to be helping us out a ton on the backside of our workshop today. All right. So I am super excited about this kind of next level Python workshop. And again, don't let that experienced part worry you. No worries at all. Kent makes things super accessible while showing you some custom things that you can do with Python while using CodeHS. So it's pretty exciting. So we're getting through our virtual check-in right now. We're going to get you enrolled in your section very soon, probably after this slide. And I think I got those out of order. Whoops. We're actually going to go straight into Ken's Tracy's Ghostly Challenge, and then let him talk about his amazing program that he has, or programs that he's set up for us today. You'll have a chance to actually take a look at that code and fork the code too, so you can actually use it for your own classrooms. Then we'll see what we have left for time. And I'm going to take you through a few things like the sandbox. How do we get from using those sandbox things and creating those cool things? How do we add those for our students? How do we let our students use the sandbox? And how do we customize a little bit? And we'll wrap all that in towards the end. If there's anything that we don't have time for, I'm actually going to add some additional resources into that section so you can peruse those whenever you have a chance to. All right. So if you do not have an account, please take a moment to head out to codehs.com/sign-up to create your free educator account. Whoops. I'll leave it here for just a moment. If you do have an account, you can definitely go ahead and sign in now to CodeHS. And if you have any problems creating an account, don't hesitate to drop a message into the question parking lot. That'll be the best place to do it, since we don't want to miss that. You might need some help. Welcome, welcome, Alicia. Oh, I'll be heading back to Atlanta in a few weeks. Thank you for joining us. APCSB. I was an APCSB teacher. I did not do APCSA. I really wanted to, but it never worked out. Awesome. All right. So once you're signed in to CodeHS, we'd love for you to head out to codehs.com/go/07E87. And Don has tossed that link into chat. So sign into CodeHS, click that link, and you will be able to enroll in the workshop section for today. We're going to keep an eye on that on the back end and make sure that people are getting enrolled. And again, just like with anything else, if you've got questions, don't hesitate to toss a question into that parking lot for us. and we will make sure that we can get you into that section. Just gonna go ahead. There we go. Oh yeah, we're all getting enrolled well. Let's see. Gwendolyn, can I sign back into the previous workshop or should I enroll in a new one? So this is a brand new workshop section, so you will want to enroll in this section as well. That's a great question. And you'll still have access to all of those other sections too. I'll actually leave those active throughout the summer so that way you can get out there and get back into those to get those resources at any time. All right. Looks like we've got people enrolling pretty quickly. So we've got our pros here, our CodeHS educators. You guys are amazing. So thank you for getting enrolled. Again, if you've got questions, definitely don't hesitate to let us know. All right, one last link. And this one is an important, well, they're all important, but this one is our attendance link. So once you've actually created your account, we'd love for you to go out to codehs.com/python-exp-attend. And that is going to check you into the workshop and allow me to send you a certificate of completion for 2 hours at the completion of this workshop. So you'll want to watch for that certificate to come in your email. I should have that sent out to everybody by this evening. If you don't see it by tomorrow morning, send me an email and just let me know that you did not see the certificate. It will be coming from the hello@codehs.com email address. So you'll want to watch for that as well. Every now and again, it goes to spam. We haven't been seeing that happen too much, but keep an eye out for that. All right. All right. Thank you, Don. Don just tossed a couple more links into chat. We have had numerous people join. So if you just joined, Don tossed the slides link into chat and the question parking lot. And I'll go ahead and click this link so you can see what happens. What should happen? Perfect. Yep. This is all you should see. If you don't see that, go ahead and toss a message into the question parking lot. That way I'll know that we need to make sure we give you credit for being here. It's so easy. We try to have an easy button available for all staff members. All right, everybody. And I think, I don't know why I had introductions in there twice, but that's okay. If you have not introduced yourself, go ahead and do so. I think I had it there and then I moved it, but I must have just copied it, didn't cut it. That's all right. Okay, now I'm going to stop sharing my screen. And while we're transitioning over to Kent, let him go ahead and start sharing. I'll just reintroduce him. Kent Pendleton is one of our amazing CodeHS educators. And we are very, very lucky to count him among our teacher trainer group. And so Kent has brought us some amazing workshops. I absolutely love his programs, and I think you are going to be so excited to take part in this today. So Kent, I'm going to turn it over to you, my friend.
Okay. Okay, it is really nice to see you guys today. Thank you so much for having me. Thank you. I feel so privileged that you're taking some time out of your summer to enjoy some Python with me today. And I really enjoyed putting this together. I hope that you'll enjoy it as well. Let me tell you a little bit, kind of an overview of what I'm hoping to accomplish. We've only got like an hour and a half or so to talk about a lot of cool things. And so part of what I'm going to do is give you a philosophical approach that I use and how I train my students. And then I will be providing, or Lori's already provided for you, the sandbox with all of the code. And most of it's already complete. So you don't have to worry about sitting there coding it all out. It's all going to be done. The only thing that we might do is to kind of give you a flavor of things. I created one little program that's not complete, and we might do a little bit of that just to give you a sense of what things are like. But anyway, my assumption that I'm going to use with you, like I use with my students, despite how much training they've had, I try to make the assumption that Kit kids and people I'm talking to don't have any idea what I'm talking about. And I'm usually right, they don't. But I like to assume that people don't know squat and like to try to build from there. So I may be insulting your intelligence a little bit, but I like to see how things all connect. And hopefully today you'll see how the Python world connects with how Tracy the Turtle does her job. And part of what I like to do in the Python class in my real world is our Python class is the beginning point for computer science training. And many of my kids go directly from Python into AP Computer Science with Java. So I'm using this as a way of building an infrastructure in their head so that they already know about creating variables and they know about logic flow and all that stuff. But we all know in Java, you can't do anything unless you start talking about classes and start talking about objects. So as early as I can in my training with even the beginners, I like to start with objects just as quickly as I can. So I'll be showing you kind of why I do that, and hopefully it will make some sense to you on what's going on. And before I get into my slides and show you some code, what I'm doing here is actually something I used a couple of weeks ago. I do summer school at my school. And so a couple of weeks ago, we had an introductory course for kids that want to get on the fast track with programming. And so it's a week-long introduction to Python course. For us, it's like a trimester's worth. And it's an 8 to 5 class, Monday through Friday. So I had kids coming in there that didn't know anything. And so what you're seeing is the culmination of kind of a week of training that I did with beginners to get them from, I don't know what Python is, to, hey, I kind of know what Python is now, and I hopefully liked it. And maybe I even want to learn a little bit more about computer science and tackle some Java. So that was my end game. That was my hope. And so that's kind of what my hope is for you, is if you already taught Python, then this might tie a few things together in your head. If you've never touched Python, that's okay too. It might give you an overview. But keep in mind what my goal was, is I want kids to have a pretty good foundation leaving this training into why objects are important and why I need to continue my training with Java and stuff of that nature. So that's kind of my thought. Okay, so you kind of know what my thinking is as I go into this. And then I've got a few more slides that will talk about kind of my objectives, and it'll put some things in perspective, I think, for you on why I do what I do. What I do might not fit your environment, and that's fine. Since we're all professional educators, we all deal with different kinds of dynamics, some of things that we control, sometimes we can't. But I think we all love computer science, whether we're teaching it or not. We wouldn't be in this field if we didn't have a passion for it. So I'm just showing you what I think is a kind of a passioned, fun exercise in learning objects from the perspective of Python. And even if we can't put it into our classroom, at least it puts something in our head to understand how to access that, at least those ideas with the student learners, and hopefully build some thinking processes in them, and maybe some excitement. Says, oh, I kind of like this. It makes sense. And so that's my hope. So let me see if I can share my slide with you here. I always get nervous doing this. So let's see. So I'm hoping at this point you can see my slide. Now, I apologize. I'm a big Stranger Things fan, and last week I was doing a Photoshop class, and I just had to see if there was a tutorial on making the Stranger Things kind of logo. So I found one, and it worked well, and mission accomplished. And so you see there, Tracy's Ghostly Challenge, and I've titled that thing an immersive Python coding experience with CodeHS. And the reason I'm using immersive will become a little bit more clear to you in just a few moments. So if you're a Stranger Things fan, I know you can't wait until the new episodes drop. I think, when do they come out? Tomorrow or Saturday? Can hardly wait. But in the meantime, we can do some Python. So anyway, as we go along here, so if you are a Stranger fan, you know that there's a world called the upside down. And sometimes when we're programming and if we're students learning things, we might feel like we're trapped in the upside down. We're in a really weird world that kind of looks like normal, but not really. And often we're faced with mysteries. And I teach my students from day one in all of my classes, you are a detective. That is your job. And you have to learn how to look for clues, find out what's important, find out what's not important, and have to ask questions. You have to ask millions of questions. And so you might feel like you're trapped in the upside down, even as a teacher sometimes. But you see there in my little message there, it says, we're as coders, we often assume the role of detective and we solve nonlinear problems as they develop. And I want to emphasize that. Unfortunately, many times we give kids the idea that computer science is a linear endeavor where you're teaching things in baby steps and that's the way things always work. But you and I know that doesn't always work that way. You hit things where, hey, I need something now that will do some kind of task and I've not learned that yet. I wonder if I can do some research and find out how to do that myself. So just like the kids that went to the upside down, they had to explore options, often under threat of death. Well, we're having to explore options too, sometimes putting things together that we didn't know were going to be going together. And so that's kind of my philosophy is I'm teaching kids how to be detectives. And so, and sometimes that means we might be a little bit uncomfortable, but we got people that love us, teachers love us, and they're going to help us. So anyway, therefore, having given that, my approach to computer science is kind of twofold. You see in the slide there, that I've got a little picture there on the left of a little baby crawling. And I think of that as baby steps. And so I have a dual approach that's worked well for me. On one hand, I tell my students the first day, I will be teaching you in a baby step fashion using the CodeHS platform. And we're going to learn in a very linear fashion how to create a variable. And then we're going to eventually figure out how to make a function and or talk about making decisions and or talk about loops. And we're going to do lots of practice on that end. And CodeHS is fantastic and marvelous in that capacity of incremental development. You baby step and then you start crawling, and pretty soon before you know it, you're walking. If you take that approach only though, think about it. If you've seen the curriculum in Python, they might not see classes until maybe toward the end of the year. And you know how the end of the year is, we're all nearly dead and the students are wanting to get out. And so I think, gee, if I can start getting to think about classes early on, that's really a good thing. So I tell them that we're going to learn two ways. On some days, we're going to start with the CodeHS platform and we're going to baby step through doing the lessons and exploring the ideas in isolation. So we'll be learning about creating a variable in a single lesson, and then we'll be creating, arithmetic in a single lesson. And then eventually we start putting them together. But then I tell them, we're also going to do something from what I call the immersive technique. And that's where I like to start with a project that I know they can't do, but yet they can understand it. In this case, this summer, I said, let's do the ghostly challenge. Ooh, and let's see if we can use Tracy to make a cute little ghost. And I stole the idea from CodeHS. I do their JavaScript stuff and I do their Java stuff. And in the JavaScript area, they had a little thing where we made a ghostly little shape and it was fun and we move it around. And I thought, well, I haven't done that with Python. I bet Tracy wouldn't mind making a little ghost. And no, I don't mind. So we were going to make this ghost. And so it presupposes a lot of things that on the front end you couldn't do, but yet anybody could understand that project. So I tell the kids, on one level, you're walking maybe from the left and you're doing baby step, but on the other end, we've got a big, massive project and we're going to develop the stuff as we need it to pull that off. So we might not be learning things in a very linear fashion. We might be pulling some stuff from here and pulling some stuff from there and build things as we need them. And in that regard, I tell the kids, this is a lot like cooking. We're chefs in a stocked kitchen with lots of accessories and every ingredient we ever needed. And we need to be able to pull things as we need them to generate what we want. In this case, we want Tracy, the turtle, to make a ghost. So the idea there, as I say, I often give, in fact, I told them this a couple of weeks ago, I said, it's like I have a minor in Russian, I've forgotten everything, so I would be terrified if you did this to me, but it's like, okay, we're going to drop you in the middle of Moscow and we're going to give you Google Translate and we're going to give you some money and we're going to maybe even give you a guide, but you have to learn things as you need them rather than asking somebody where their necktie is, which isn't really helpful when you're trying to get a hotel or something like that. So I'm going to drop you in and we're going to learn things as we need them. And so we might be learning about lists well before we see them in the CodeHS area in the baby step fashion, but at least when you get there, you'll see, oh, this is why we need them. So I use this a lot as a pre-teaching mechanism, giving them some context of why we might need this. And hopefully giving them the idea of how to answer their own questions, formulate questions, answer them, do reconnaissance with the internet of how to do what they do. So if you look at my note there, to me, there's benefits of this, is that they're learning they're learning things in a contextual fashion. That's why I've got the picture of the thing from Russia there in red. And then you'll see there, I've got something called audience diversification. The other reason I do this is that my population of kids, I'm the only computer science teacher, so they got to put up with me. They don't have any choice. And sometimes I've got them for 4 years. Sometimes I only got them for 1 year. So I may have a kid in a Python class that's already had maybe some other training elsewhere. And so I've got a very diverse audience. Some kids have never seen any computer science. Some kids have. As you know, you probably have had students that have been they've self-taught. So I want to make sure I've got something for everybody. And every year I've got some kids that the baby step thing is, man, that's my salvation, because I got to learn in a linear fashion incrementally. But I have had kids that's like, hey, I've already done this since I was in 4th grade. I actually literally had a kid. Hey, I've been coding since I was in 4th grade. Oh, wonderful. I don't want you to be bored here. So this lets me address a diversified audience. I pick a project that I know that nobody can do, and then we're working the big project from one angle, we're working the baby step on the other angle. It works well. This lets me hopefully capture kids' imagination, which I think is important. And then also I worked in industry. I actually am a rocket scientist. I used to do some Star Wars research with the SDI program with Sandia Labs. And so I am a rocket scientist, actually. And so in the real world, so to speak, that we always talk about, you're often dumped into the upside down where, hey, I don't know how to do this, and you're telling me it's due next week. Okay. So I got to hustle to get the work done. The other thing you see there is a little blue gear that says above it, reverse engineering. So many times I will give students a complete project and then we dissect it. What's going on here? Because, they can go to the internet and they can look up how to do something. There, like oftentimes in computer science, you see a tic-tac-toe game. Well, any idiot can go and Google how to do a tic-tac-toe game, and there it is. But does that mean you can understand it? Can you take it and print it out and say, okay, what's going on here? So I think if I can get kids to be able to do that, that's a good thing, is to reverse engineer. So anyway, this is my dual prong approach. That may or may not work for you. It has served me well. And let me tell you a little bit more about my educational environment. I've only told you a little bit now. I know you went, hey, where's the Python? Where's the Ghost? Yeah, I know. But I want you to understand why I'm doing what I do, okay? So I've got, in my environment, this is an honors program, yet the students have a wide range of abilities and backgrounds. I try to survive and have something for everybody there. Our Python is an intro language leading to APCS in Java and or game development in JavaScript. Here's the other method, pardon the pun, method to my madness, is that you cannot darken the door of web design and object-oriented and Java stuff unless you understand about objects, unfortunately, because of course we've got the DOM, the document object model in web design and in web programming. And so from day one, you kind of have to understand that if you want to have anything fun going on in your web pages. So this is another reason I try to hop on objects as fast as I can. Also, I've got an environment that many of you might kill for. I do have fairly small class sizes. I'm going to have class sizes that go anywhere from 8 to 24. So this works well when you've got a small group of kids. If you've got a larger group of kids, this idea may not work for you, and that's fine. I'm just trying to plan an idea in your head on options that you might have. Also, I have for over 20 years, I've been doing this. And so I for many years, I developed my own curriculum because I feel comfortable writing stuff that I know how it works. So I've kind of got curriculum development in my blood. So I feel like I'm a slacker if I'm not creating my own stuff. Also, I often will have kids take classes all 4 years. So I got to have a variety of things and hopefully keep things interesting. And I will say, I said this already, I'm the only computer science teacher. So I'm my own boss, which has got its pros and cons. And one reason I love being with you guys, because I rarely have people that I can talk to that know what I'm talking about. if you're working with a team, this approach might not be the best for you. That's okay. We're still just getting an idea of how to fit in objects into Tracy's world. And then last of all, I do have a summer school on-ramp. So that also affords me some ability to do some things that in a little bit more relaxed environment. All this is to help you understand why I'm doing what I'm doing. It may be crazy, but it's been working for me. And I also have a little link there on the bottom of the slide. That's a site that I put together several years ago. It's kind of been, I'm in the process of updating it. It's woefully out of date. When COVID hit, I dropped all development on that. So it's sat there crying its eyes out for 2 years without me doing anything with it. And I'm redoing it based on stuff I learned in CodeHS with Bootstrap. So hopefully it will have, before the end of the summer, it will become alive again. But it is something I use with all my classes to show kids how things work in the real world. Okay, we're writing a program to jumble letters. Here's how it works in real life. And so then, since that's all written primarily in either JavaScript or PHP, they can actually, if it's not PHP, they can go and look at the source code and say, oh, here's the source code in JavaScript. I don't know JavaScript, but I know Python. I bet I could read this and translate it into Python. And many times that's what I have them do, is kind of cross language stuff. But anyway, enough about me and enough about my environment. Let's get on with things. Oh, I said that, and here's one more slide. That's a snapshot of my classroom, and it kind of captures my philosophy. You see there, I've got a cardboard cutout of Shaggy and Scooby-Doo, and because I'm reminding them nearly every week, they get so tired of this. You're a detective. You're supposed to be uncertain about things. You're supposed to filter things through the grid of, is this important? Is this not important? Asking questions. And so I'm also often asking them, what does Scooby do? Sorry. And then there's another quote there from Dr. Alfred Lanning in the movie I, Robot, which I recommend. I show it to my classes. It's a marvelous example of how to ask the right questions. And so the holograph is always saying, my responses are limited. You must ask the right questions. And sometimes I refuse to answer a question unless kids ask it the right way with the right terminology. And then you see there a little quote above Shaggy. This is my philosophy also. If all this seems kind of zany, it is. My experience has been, what we learn with pleasure, we never forget. And I try to infuse stuff that's unexpected in the classroom. They don't expect to hear about Shaggy and Scooby-Doo. They don't expect to hear about the Three Stooges. All the better to capture their imagination. And so you see there, this is my philosophy. Primary responsibility is to spark imagination, help students fall in love with CS, and to learn to ask the right questions and find their own answers. So that's my mentality. Having said that, now are we going to do any Python? Yes. So having said all that, my objective is to teach functions as soon as possible and to teach objects as soon as possible. And that way, that's kind of the immersive idea. Now, to do that this year, what I did is in the Python class, after like one day of class, they've been working with Tracy the Turtle and all that. And I give them what I called Tracy's Ghostly Challenge and said, okay, here's a picture of a ghost and you have an hour and do whatever it takes to draw as much of that ghost as you can. And I'll actually say, okay, now I don't actually show them this picture with the ghost in different colors. It's all one color. So they need to realize, oh, it's got a head, which is a circle, and then it's got a body that's got a rectangle that's the same size as the circle, and then it's got some little feet that are circles at the bottom, and yet they're fitting in a line. So they have to figure all that out somewhat. So I'm interested to see, this is kind of like a free response question. I just want to see, can you draw a dang ghost? Well, some kids, in fact, I gave them that picture that was the opening slide with the ghosts under the magnifying glass. I actually gave them 5, said, get as much of this done as you can, go. And I actually timed them. Well, one kid came up with 4 ghosts, and that's really fantastic. One kid struggled to get a shell of even half a ghost. And you know what? That's okay too, because I want them to see that it's normal to fight with something, especially when you haven't had as much experience as maybe others have had. And then what they're having to do also, of course, is if they know that the only way you're going to survive this is to create functions, because I've got to draw a head. And if I've got to draw a head for 5 ghosts, it'd be nice if I had one function that draws a head, for heaven's sake, and one function that draws feet, for heaven's sake. If I've got to replicate it all with individual statements, it can be done, but it might be 100 lines long. Wow, it would be really nice. And that's what I'm mentioning in the link there. You see on the slide, it says explore the Ghost of a Chance app. And that's one of the things we'll look at perhaps in a minute. To have a ghost of a chance on this problem, you have to break it up into the idea of functions. And so anyway, and they will have already seen functions from my training and maybe from some baby step stuff with CodeHS, but they need to know, I need a function here, maybe a function called draw head and draw eyes and draw body. Hopefully they draw those conclusions. But I broke the anatomy down into objects, a head, a couple of eyes. Oh, and the eyes got pupils. So early on, I start using the language of so-and-so has such and such. And if you're a Java programmer, you've heard that kind of thing about maybe attributes or instance variables. And then we want Tracy to use those functions. And then, of course, you know that functions embedded in classes give rise to methods, or the idea that a function, when I put it in a class, whatever the heck that is, I have methods. So anyway, this slide is just showing them they had to break this stuff up into pieces. Now, I'm going to keep going for a little bit, and maybe we'll look at we'll dive in the code. But the next slide is a philosophical thing with me. And you'll see how I did this when we look at code in a moment. This is a throw or what's the word? Kind of a shout out to the idea of Java. You know that in Java, day one, if you're using APCS normal teaching techniques, you have what I call the driver code or the runner code, and inside is the so-called main method and whatever the heck that is. In other words, it's a little bit of an orchestrator that kind of calls the shots on stuff. I also try to get the students to see that from day one in my classes, that the main event is not someone that's the chief cook and bottle washer that does everything in a company. Here you see Bjorn Strusup. I'm not sure I'm pronouncing his name right, but I remember this picture of him. He's the creator of C++. And then he's there sitting on his desk with his feet propped up, and I say, that's like the main method. The main event in any program should be the delegator saying, hey, you go do this and you go do that. I'm going to drink my coffee and watch what you do, but your job is to do the grunt work, and I'm going to orchestrate it. And that's how I like to organize thinking in the minds of the kids. So I just say that the main event should be a delegator or conductor, not the chief cook and bottle washer. And so the boss, so to speak, is going to have everybody else do the dirty work. And that's the philosophy of what you're about to see here. Because when I go in, when I am writing a shell for the projects that I do, okay, so think about this. When kids are doing the CodeHS stuff, it's a very linear approach with mechanized snippets of, we want to write a variable and print it out. Yay. Okay. Now the next exercise, we want to write a variable and get another variable, add them together, print out the sum. Yay. Okay. So it's very one task oriented, but we're thinking larger picture here. And so my suggested organizational scheme usually has them creating some header comments, which is a professional standard. When I worked in industry, I ruled the day when I inherited notebooks of code that nobody ever commented. And that happened. And so I had to decipher the code and figure out what was going on. So I'm a big proponent of header comments and explaining what's going on. And then I have little cubbies. I have little comments there that talk about, you have a region for imports, global variables, classes, functions, and setup stuff. And then at the bottom, I have that thing called the main event, which is kind of like an outline of things to be done. And you can read this, and Lori's made it sure that you have access to this stuff later. So I won't read this to you as such, but just think about, we ought to have somebody in charge that's orchestrating all the other pieces. And so the main event, think of the guy with his feet up on the desk, the gal with her feet up on the desk, telling others what to do. And I say it's like a conductor of an orchestra. The conductor doesn't play the clarinet himself or herself. The conductor points at people and they do what they're supposed to do when they're supposed to do it. And that to me is a well-organized program. And I start teaching that organizational scheme early on too. So then we get in to a situation. Now you see here, I've got something, it's probably the last problem in the sandbox, which again, we'll look at in a moment. I'm giving you kind of my crazy idea of thinking from the top down. What possessed you here? What am I getting at there? I'm looking at an outline of the last part of the program. Notice where I'm at. I'm in the main event. I've got a comment there. I've got a little printout statement that's saying what possessed you. That I usually give cornball names to all the stuff that I do. And the kids, I worry about their eyes getting stuck at the top of their head with how many times they roll their eyes at me, you know, but if it keeps them awake, so be it. So I teach them, hey, in every program, you want to make sure you know it knows what you're doing. And so I like to have them print some kind of header that says, hey, at least I got the heading to print. You know, if the heading doesn't print, I know I've got real trouble. And then usually I'll have the main event print something at the end. Hey, thanks for using our program. So if I'm stuck in some kind of infinite loop, I might know, hey, I should have seen an end to this. At any rate, I talked them through the big ideas. So we want to get a picture of Tracy. I mean, a picture of a ghost. Well, we need a background color. They might not have seen this yet. So, but does it make sense to you? The conductor is saying, I want a background color of light gray. I want a certain number of ghosts. I need those ghosts because we identify them as object-y kinds of things. They need eye colors. Well, what kind of eye colors do you want? Well, I like white and black, please. Oh, look, that makes sense to me. I don't know what it means. I don't know what the heck a Python list is, but I do see that I've got some eye colors that are well named and they're white and black. So then I might say, you know, you will encounter later in your adventures the idea of a Python list. And a Python list is nothing more than like a hotel that holds multiple pieces of information. The information is separated by commas and they put them in a little box because the hotels are in a little box. And we give it a name. It's one-stop shopping for multiple pieces of information. And I'll say, if you don't understand that, that's fine. But I'm in the main event. I'm not worried necessarily about what's going on here. I'm just orchestrating some events. Let's create some eye colors that are white and black. Oh, and by the way, if you look at the pupils might be going in different directions too. So I've got, oh, look, square braces. What children did I say that was? That's a list. Oh, and you know, by the way, sometimes we call them arrays if you're in other languages. So anyway, we've got the eye directions going in different directions. And then the eye data. Now, this is the more complicated one, is that, hey, there's lots of things that make eyes eyes. So we've got eye colors and eye directions. I wonder if I could put that in one big grouping called eye data. And look, I created a little list called eye colors and a little list of eye directions. Oh my gosh, do you think it's possible that Python will let me put a list within a list? And so now before we know it, they've got the idea of a two-dimensional array without me frightening them with all that complexity, because right here, it kind of makes sense in the context of a goofy little ghost that, yeah, the ghost, we got a lot of things about the ghost. We need to know its colors and its directions, the way it's directed. We still haven't even talked about the placement. But now I want you to think about this. And this is getting into the big idea, thinking about a big idea and working down. I haven't mentioned the thing about the eye sizes or the eye placements. Oh my gosh, you can't have a disembodied eye. What are we going to do about that? Well, what governs the location of the eyes and their placement and their size? It's the head of the ghost. So I can't really say anything about the eye's specific location and size until I know the size of the heads of the ghost. So what I'm hoping to capture in their mind here is that these objects are interrelated. And so I can't really reliably talk about an eye until I know the bigger picture of the head of the ghost. So if you've survived this so far, I keep going and say, well, we've got some colors for our ghosts. They're red, orange. Oh, look, children. I say, I know you're not children. Look, we're using lists to hold data. And this is so convenient because I can have a multiple colors. I can have red, orange, yellow, etc., all the way up to lime ghosts. And look, I'm going to make 12 ghosts. Do I have 12 colors? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Ooh, did I miscount? You know what? There's always method to my madness, because some kid will usually say, well, wait a minute. We haven't started making ghosts yet. I really would like a ghost, but you gave us 12 ghosts and we've got 11 colors. What if we run out of colors? Oh, I'm glad you asked. You think I designed it that way? Could it be that we run out of colors? Yes. We've got to have a contingency plan. And our conductor is hoping that the smart, we're hoping, I'm sorry, the administrator was yelling at me, which is common. We have to have the conductor doesn't want to worry about the fact that they run out of colors. So that's for the grunt worker to do. But the conductor's just providing those colors. Now, I'm about to go to the next slide, but this is the kind of stuff I tell them. Remember, this is immersive. I think everybody could understand what we're trying to do, even if they don't know how to do it. So I'm painting that framework in their head first. And then this is kind of like a reverse engineering. I'm essentially showing them the driver code or the source code on the front end, and then we're building it backwards. So this is reverse engineering in my way of thinking. Also, while I got you there, a captive audience. Another great movie that when I can, I show it. It's a movie called Paycheck. Paycheck is a great movie of talking about reverse engineering and working your way backwards. And so if you have the ability of showing media at times, like you have a professional development day and you're gone and you want something that's educationally sound that the kids would enjoy anyway. So it's a great movie. And I'm using that idea here a lot. Anyway, so am I possessed? Yes. My conductor is creating a listing of things to do to make the ghosts. And I started out by saying, I've got a little ghost yet, but it's not been manufactured. Oh, well, you mean I've got a ghost? I don't know anything about it. That's right. Well, why don't we say it's none? Why don't we just say we don't have a ghost? Oh, darn. So there I talk about the idea of creating a variable that is not yet in existence. So I want to start getting them to think about the null object. Okay, see, again, I'm always got Java in my mind so that when I have them the next year, they haven't run screaming and they come up and sign up for Java next year. You remember we had the ghost and it wasn't there? Yes. Oh, well, that's the null object. So anyway, with that, now again, we're looking at the main event. I go to the next stage of the main event. It wouldn't all fit on the same slide. So now we're in the second part of the main event, continued. Now, I tried to color code this a little bit. Now, I like to use what I call breadcrumbs. Breadcrumbs are statements that let me see that something actually happened. And so, in fact, the movie I, Robot inspired that. They talk about following the breadcrumbs from the story of Hansel and Gretel, which is actually part of the I, Robot movie. You really need to see that movie. After you watch Stranger Things, go rent I, Robot. If you haven't seen it, you won't be disappointed. At any rate, I put a breadcrumb there saying we're drawing a ghost. And then notice it says string. Oh, actually, I forgot. I see that. We've got a little loop there. So they might not have even seen loops yet, but I'm showing them the top-down idea that, hey, we might want to do lots of things. How many ghosts do we have to draw? 12. Okay, well, wouldn't it be cool if we could cycle some information and draw 12 ghosts at once? Oh, that would be so cool. So I showed them the structure of a for loop for G in range num ghosts, whatever that means. And I said, now, if you're nervous by this, that just means you're normal. You're going to be seeing some walkthroughs with loops in isolation in CodeHS, but I want you to see that there's a way that we can cycle commands in a cyclical way, and you'll see how this works in a moment, because voila, I've got a little print statement that's going to show me that I'm drawing the ghost one at a time. And so they might not, this looks like Aladdin saying abracadabra or open sesame at the Cave of Wonders. Yes, I use lots of movie references. So does Aladdin know what abracadabra means? No, he just knows that if he says the magic word, hopefully the cave of wonders opens. So we're going to list this incantation, and then when we run it, it will make sense of how it works. So essentially, I'm going to say we're drawing ghost 1 of 12 or ghost 2 of 12 or whatever. Moving on down the road. Now look, so now we introduce the idea of randomness. We talk a little bit about, wouldn't it be dreamy if we had an engine that made random numbers in an interval of random numbers? Yeah. Well, voila. Python has that. Cool. And then notice here, and we'll run this in a moment so that you won't think this is all in isolation. It does actually work. So I need a ghost. It's got to be randomly placed. Well, my random numbers have been generated. I don't know how. It's magic, but now I appeal to their math. I'm a former math teacher. They kicked me out. Now I do computer science. The center, what would your math teacher call something that's an XY pair? An ordered pair. Wouldn't it make sense that we could locate our ghost with an ordered pair? Oh, that would be wonderful. Well, we don't call them ordered pairs in Python. We call them tuples. Now I say tuples, you might say tuples. I say tuples, you say tuples. And so notice automatically they're beginning to see data structures without even having been taught data structures, because data structures are so handy. And so anyway, we talk about that that's going to place, and now look what's going to happen. We generate a random number for a head radius, a height, and a num feet, because these are things that a ghost has. We already talked about the anatomy of a ghost. Then I do a little bit of stuff with the color. We may come back and look at that in a moment. And now this is the moment you've been waiting for. And they haven't even done any of this yet, but this is the main event, the conductor telling me what the minions are going to be doing. And our ghost does look like a minion. That's kind of fun. A ghost shall be assigned, ghost. And I start telling them this. What if we had specialized functions that acted like factories, and we supplied the parts that those things needed in a certain order, and that factory knew how to manufacture them and put them together as a single entity, in this case, a ghost? Well, there is such a function, I say. It's called the ghost function, but it looks different than some other ones. It's because it's a specialized thing that's being birthed using something called a class. And a class is nothing more than a factory that creates stuff. Okay. And notice, what does my ghost need? He needs a center, a head radius, a height, a number of feet, the eye data, and a color. And if that is provided in a reasonable way, I can make a ghost. And then, now this is the big idea I'm trying to capture in their head. And you might be thinking, I'll have a student revolt if I teach like this. And you might. And you might be fired because you're an incompetent teacher. And you might. But I'm trying to get you to think about the big picture. Even if you never use that, that's fine. Is that this is 20 years of Java teaching distilled in a way that I'm hoping someone understands the ideas. So when they start seeing it in real, it kind of puts some meat on the bone. So I'm thinking, what if a ghost has all the properties encapsulated in it so it knows how to make itself? And what if it has all the functionality embedded with it that it knows how to draw itself? And look what I'm doing here. The main event is doing nothing more than orchestrating an event that all these minions are doing back somewhere else. In fact, a ghost knows how to manufacture itself, and a ghost knows how to draw itself. And so now the poor conductor is no longer having to do all this himself or herself. He's just pointing, directing the action. So we draw a ghost. What happens after that? Next slide. Well, I drew some random ghosts. You know, bad things happen when you draw random ghosts, right? They get placed off the screen. They're the wrong color. You don't have the right kind of contrast. So I discovered this quite by accident, that if the ghost was white or if it was yellow, The eyes looked like they were really goofball. They looked like my code was malfunctioning because white eye backgrounds on white ghost bodies look crazy. So I had the idea, well, what if we put eyeliner, eyeliner on our ghosts if they have a white body or white or yellow body? Well, I'm glad you asked. And this is where, again, they may not have seen compound logic yet. I'm just showing them how to decipher some main event code. And that's the thing I actually tell them a really dirty secret. I'm going to tell you, this is on tape. This is not a good idea, but I'm going to tell you anyway. I didn't like Python at first. I was horrified. I taught Java all these years and loved and worshiped the curly brace brackets. And now where you're telling me we got a language that uses white space for code structuring, have you lost your mind? Because I used to say, spaces are evil, spaces are evil, spaces are evil. And now what do we use in Python? Well, not really spaces, they're tabs, but I tell them, hey, I'm a convert. I'm sorry, Python, I said all those mean things about you because you read kind of like language. Here, students, you haven't even seen a compound condition, but look how nicely this reads. If a ghost has a body color that's white, or a ghost has a body color that's yellow, what are we going to do? Hey, Mr. Ghost, yeah, let's put on eyeliner for the left and right eye. What could be easier? Notice how nicely it reads. And we love you, objects. We love you, objects. We love you, objects. Why? Because the main event simply has to say, hey, Mr. Ghost, Miss Ghost, yes, you've got a body object. Yes, I do. Well, your body object has a color. Yes, I do. Let's look and see what it is. I can peek in the ghost and see about its properties. Now, of course, the Java teacher in me is horrified because we're not using accessors, but I'll get over it. Here's my point. I can start teaching with objects and they've never even seen a class. I haven't even started teaching the code yet, but I'm hopefully embedding these ideas in their head and I can reference back when I need to. Also, the benefit of this, if this is source code, source driver code, and now kids want to go to the internet, say, now, see, this is fun. I do this. If you go to Tech Novice Tools, that's my site that I wrote. If you go to any app, you all know that you can find the source code. So you can open the source code if it's JavaScript and you can see everything I've ever done. And what happens that's magical, and at this point I'd probably show them, if you understand just a little bit of what I'm saying here, and if you don't, that's okay. You're going to go through the CodeHS lessons and you're going to learn it incrementally, but I'm giving you the big picture. If you go to most source code documents and look at JavaScript, you're going to see things like a ghost.body.color. What's it talking about? An object that has a property that I can check. And so in JavaScript, you will see this left and right. And so here they're seeing the dot operator. In JavaScript, they see the dot operator. In Java, they see the dot operator. And so I want them to see that just as quickly as they can. So anyway, if you're a white or yellow ghost, we'll put eyeliner on you and we can see your eyes. And then, ooh, and look, now, pet peeve. Did I tell you I hated Python at first? Yes, I did. It's on tape. I'm sorry. But I love it now. I love it now. But, you know, I just can't go over the fact they use tabs and stuff, and there's no curly braces to tell me when I reach the end of the road. So I require them to put a little hashtag end loop there. I want to know where things end, because you all, if you've taught, if you're an experienced Python teacher, you know that people put things at the wrong indentation levels, and that makes you lose your mind. So if you mark where things end, advantage. So now I'm out of my loop, and then I've through manufacturing ghosts, and I put a little thing here. You can see applause to the conductor. What did we do? We created lots of little ghosts there. You can see they've got randomized, they've got random placement, and I couldn't resist doing this. The Java teacher in me couldn't resist. What you know is that if we've gone through a loop and I starts at 0 and goes up to 11 or whatever, if we're using zero-based indexing, when I reach the end of the loop, the counting variable gets updated. And so if we looked at our lesson said we had ghosts that go from from 0 to what you know is that in a loop in Python, even it uses zero-based indexing. And so that's one reason I put in the ghost numbering the way I did in the driver code so they could remember about zero-based indexing. So I'm thinking, all right, will it know who G is when I get out of the loop? And so that's why I put in a little thing, a little statement that shows what happened at the end. So you can see, all right, again, I'm a big Batman fan, and I show them a clip of Robin saying, "Holy mackerel, Batman," and all this stuff. So they know, "Holy ghost, Batman." So I wanted to print out the ghost. Does it know about our ghost once we leave the ecosystem? Yes, it does, because I declared that the ghost existed as none early on. And because so we talk a little bit about scope. Ghost was invented before the loop, so it's known about after the loop. This is a good way of showing that. I love this. I love my job. So what would happen if I print out the stringized version of a ghost? Will it tell me you've got a ghost at so-and-so with color thus and such with eyes that go crazy? No. Holy Ghost, Batman, what did it say? In the main module, I've got a ghost what? Kaboom! A ghost object. Wow. And then, but what if I want to know more about that ghost? Well, I've got a ghost color, a white ghost, and there he was. He's so cute, is placed at such and such location. And so notice, I love you, Python. I'm sorry I said mean things about you because you'll let me print out a string-eyed version of a tuple as an ordered pair. I think that's so cool. I would hate that in Java, by the way. So here's the deal. They've got a top-down view of ghost manufacturing, and they've maybe not done very much code at all except in CodeHS, and they've maybe seen functions at this point, but hopefully they got a top-down view. Now we start going and getting grungy with this, but I want to say one more thing about this because I think it's kind of cool. You remember we were going to do 12 ghosts, and we all had 11 colors. And also, if you look at my output, you're a detective. You're a detective. What do you notice about the ghosts? I would say the students. Are there 12 of them? No count. Students, what do you notice about those ghosts? And I would sit there and wait until somebody says something. They were randomly placed and randomly made. What do you notice? Do you see it? I'm not going to embarrass you by calling you out. What you should see, they're all different colors. I wanted to have different colored ghosts. So I thought to myself, well, how about every time I use a color, I remove it? I don't know how to do that, I say to myself. Could I Google it? Could I ask the right questions? So I'll actually stop them, say, is there a mechanism where if you've got a list in Python, is there a way of taking something out when you use it? So remember earlier the slide, I'm sorry, my responses are limited. You must ask the right questions. So I teach them, okay, go to Google, establish your viewpoint, Python 3. What's the right vocabulary? It's a list. Python 3, list, remove item. Is there such a thing? Oh my gosh, if I go back, look at the purple color. Did I tell you I hated Python? Did I tell you I sufficiently repented? I hope I did, because this is one of the things that just makes me feel in love with Python. Because look at that. It says in the purple, if the length of your colors is bigger than 0. Now, I think most students can understand it. If they're crazy enough to take computer science, I think they kind of get that. And then I'll say, hey, you know what? The length, len, is a function. How do I know it is? Because it's eating something for breakfast in parentheses. Oh, okay. If length of the colors is bigger than 0, what do we want to do? We want to get how big the array is. So I often use index as a phonetic for the room in a hotel. So I'm going to go and get the, oh, I'm sorry, I misspoke. I'm looking to see, are there still colors available? Is the length of your color still bigger than 0? Yes. Okay, let's get a random number from the listing. Okay, let's get a color from that randomly. Okay, now here's the juicy part. I Googled Python 3 list remove element. Oops, I hit the keyboard. Sorry. That's what happens when you get too excited about stuff. There's a remove function. Oh my gosh, I can remove a color I used. And then let's suppose that there's not enough colors to go around. Oh, look what I did. If the colors have availability, that means I've got enough. Length of my colors is bigger than 0. Pick a random color and then remove it. Else, make the color white. Now, I'm so proud of myself. I made it white to force the fact that I wanted to show that the eyeliner worked. Okay. Can I really make a ghost with eyeliner? Yes. And so there you see the ghost, and there's the little cutie pie with his eyeliner. All right. So the main event is done. Now, let's go. We're going to go look at code, but let's kind of summarize what we said. I'm sorry, I get kind of excited about this. This is not unusual for me. My kids think, when are you going to be done with your psychiatrist? Probably never. So what do we have here? Object. We left the punchline of a ghost object. Oh, that's spooky. A ghost has a head, but a head has a location, a radius, and a color. A ghost has a body. If you're a Java programmer, you know what I'm doing here. If a ghost has a body has a location, a radius, a height, and a color. A ghost has feet. Feet have a location, toes. See them? Aren't they cute? And a length. A ghost has eyes, and an eye has a location, a radius, colors, and a direction. Interesting. So we've got objects embedded in other objects. Now, you know that there's this fancy pants word that we all love saying because it sounds intelligent, encapsulation. And so I start talking to them almost from day 1 or day 2 about the idea of encapsulation. In fact, you know I've lost my mind because if you go in my room, I've got Easter eggs plastered all over the room, literally. I've got over 30 Easter eggs up as decorations and up on the wall and showcased on the light fixtures and everything. And inevitably, the kid, we're worried about you. Do you have a fetish with Easter eggs? Well, actually, let me tell you why. But encapsulation, so I've got some giant Easter eggs from Walmart, but I start teaching them that an object has everything in itself. Now, you haven't seen nothing with the puns that I can pump out, but in Java and in Python, they're always yakking about the self, the self, the self. What's the self? What's the self? So I'm trying to get them to see an object has everything in itself required to make it complete and independent. It has the raw ingredients, attributes that make it identifiable as a member of its class and the associated actions, methods it needs to serve its proper function. And so here I have a link to the Ghost class, which we will be seeing in a moment. So I'm trying to get them to see the idea of encapsulation. And you'll actually notice I've got Easter eggs within Easter eggs because an object can hold a smaller object. So I'm a ghost object, but inside me, I've got a head object. And inside the head, I've got an eye object. Oh my gosh, they stack. And so that's the idea that I'm clamoring for. Well, you haven't, I'm not letting you go yet. This is the slide deck of the slides that I created. And by the way, that's our cute little ghost. You see, he's got the eyes with one's going one way and the other's going wonky. It's kind of fun, I think. So this is the end of the PowerPoint. We may come back to it, but what I want to do is take you, this is going to shuffle for a second. I want to take you to the actual code. You say, it's about time. So I'm looking, in fact, Lori, is this do you need to, is this a good time for a break or before I go into the code, or do you want me to keep going?
You know what? Let's I was really into what you were doing and I forgot about the break. So let's take a couple of minutes. Let's go with maybe 3 minutes. Take a super quick break, and Kent, you can go ahead and get yourself ready to go, but let's come back at 14 after the hour, and Kent will go into his code.
Okay.
Thanks
or
for
you can run
reminding me.
screening.
I don't think anybody's going to do that. This has been fun so far. See y'all in a minute.
Kent, just for you, I put in chat the basic code from Stranger Things rewritten in Python.
Oh my gosh, thank you. Thank you. Oh, that's great. Thank you very, very much. I
Oh, no
appreciate
problem.
that. In fact, if you can, just in case I should lose that, if you could email that, could you
Sure.
email that?
Totally.
Thank you. I'm not worthy. Very good. Thank you. I appreciate
Tomorrow, I can't wait.
it. Yeah. Is it tomorrow or Saturday? I couldn't remember.
Tomorrow, the 1st.
Okay. I should know that, but.
Instead of responding to this in chat, I'm going to go ahead and just unmute. Zach just wrote into chat that this is a fantastic PD for us teachers with fewer years of experience. It's wonderful to hear the passion and wealth of experience pour through in Kent's explanations and discussions of his own materials. Great stuff. Love to see it. I only wish there was more. Kent, I'm just, I'm going to throw that out there that we need more. So Kent actually has done quite a few workshops for us. And we can definitely talk more about bringing more to you. So absolutely.
CodeHS is paying for therapy for these participants, I must ask.
I think that it's just so, I know that it's just so obvious watching you, Kent, how passionate you are about teaching, and how I just can't even imagine how much fun your classroom must be. I mean, every single workshop you've ever done for us has been like this, and just engaging and exciting. And I'm not kidding when I said I forgot about watching time for a break. So this has been an absolute thrill.
Well, thank you very much. I'm sure having fun. I love what I do, and I love being with people that I want to say you understand what I'm saying, but that might be a little, it's like, well, you don't get what he's saying. But I love my people. Nobody on my campus knows what I'm talking about. So hopefully you guys do.
You make this very accessible for any level, I feel. So Kent did a really great workshop for us on, and now I'm going to say it wrong, multiplicative digital roots. And I was so excited about it. This former English teacher sat down and researched, and then I went and had somebody else explain it to me because I just wanted to know more. So I could definitely share out the links to Kent's other workshops. And I will most definitely send out this recording, the link to the recording, to everybody who's in this session, everybody who's registered. It's always able to be found on YouTube as well. We can definitely make that playlist available for everybody. So, all right. So I'm going to stop talking. I think we're at that 14 after the hour. So I'm going to turn it back over to you, Ken.
Laura, you can still see my screen.
Yes.
Okay.
Yes,
All
looks
right.
great.
Okay. Just want to make sure that nothing crazy had happened. Okay. Well, you had a break, had a stiff drink. So you see some of the philosophy. Now let's look at the code. So what I did in the sandbox is I listed them in order of development. Okay. So if you look at that sandbox folder, these are final versions of all that I did. And so what I'll do when I create these as lessons, and incidentally, those of you that don't know this, I would imagine that you do in CodeHS, you can create your own assignments. And that's been a saving grace for me. I just needed the ability to put my own crazy spin on stuff. And the fact that you can create your own assignments. See, when I adopted CodeHS a couple of years ago, I had 5 file cabinets full of code I'd already done. And I was afraid, am I going to have to throw this out and start from scratch, or am I going to toss it and never be able to use it? Well, I'm slowly but surely integrating that into the ecosystem of CodeHS. In fact, I'm teaching a JavaScript class this week. And this is the first time I created my own course from scratch. So if you can create your own courses too. And so it's been pretty seamless. And so I thought, what I'm doing is very specialized. And the CodeHS materials, I have that open for the kids, but I also have my own too. And it's kind of like that idea I was talking about, that the CodeHS is great for incremental training and taking things a little bit a bite at a time, which is completely appropriate and necessary. And here I've got the stuff where we're looking at things from a large kind of a reverse engineering approach, and then diving down into the details as we need them. So I'm happy camper because I get both of them. Anyway, as I develop these things, I usually create a start version and then have a finished version. And I'm in class, I do the start versions, and then we finish up with the finished version. And I teach things from the perspective of a saga, where it's like Star Wars. Okay, movie 1, movie 2, movie 3. And so that's how I prefer to teach. So at every level, I start with a new bench line, and then we move forward. So it's like climbing Mount Everest. We go a little bit, we rest, I make a copy, I fork it, create another start version, and it kind of like climbing a mountain and hopefully telling a story. So I've gone to this one called A Ghost of a Chance. And so the order is, I did this first, second, third, fourth, fifth, sixth. I'm not sure why it's giving this great, I don't know if it's alphabetized or what, but I put the number so that you knew the order. So if I go to Ghost of a Chance, the point of that is, this is what many students might have had early on. If you look at this, well, actually, I'm not showing you what most students had. I probably should have done that, because what most students had is they had a situation where there was all one big mush of code. And so there were no functions. It was just, let's draw an eye, or let's draw a head, then let's draw a body, let's draw feet. It was all a mishmash. But you can see here, I went through a lesson on A Ghost of a Chance. To do this, you had to have a ghost of a chance. What do? Organization, imports, global variables. Oh, look, functions. A lot of them. Now, look at the main event. It's not ghosty yet. It's not object-based yet. But look at the organization. There's a flow. I've got a guinea pig ghost showing the various parts. Now, what does that mean? If I save and run, for those of the kids who are having trouble just figuring out how to make the parts, this one ghost looks kind of goofball because he's got different colors, right? So I wanted to be able to see. I called him the guinea pig. So, and this is what I taught the students as I developed this. I started from a blank slate. I developed the header document, which I require them to have, the header comments, then all these little cubbies, of which they might not even know why we're doing it yet. And then I have this little thing called the main event, is a shout out to the main method in Java. And I will not do anything until I get one stinking ghost made. And I'll say, why should I try to do everything if I can't even draw one dumb ghost? So let's make a guinea pig ghost. So here's where I'll go in slow motion, creating the tuple. In fact, I'll often come in here and I'll actually, this is a tuple. It's like an ordered pair. It's a specific variable, unlike head radius is 5. And I'll just talk about this is nothing more than a specialized kind of variable known as a data structure. It can hold multiple pieces of information. Not all languages have this. Python does. We love you, Python. At any rate, then you see I've got a head radius. And then this might have been day 2. In day 1, I actually drew the head in regular old Tracy the Turtle fashion. But then I made a function out of it. Because now when I come up here and I look at draw head, where are you? This is what most students would have. Most students, and this is what they're taught in CodeHS, pen up, set your position, move right forward, etc. And I'm not going to bore you with the details here. It's all here and you can play with it. And as Lori mentioned, you've got access to my code, but you can also fork it. And if you're not familiar with that, it just means, and Lori, I think, is going to go through all these details if I'll ever shut up. You can fork this information to your own copy. So then if you mess it up, then you can still get back to the original. But at any rate, I might spend a good hour just talking about the incidentals of drawing this head here. But now here's why I bring the tuple in early on. Even if you look at the curriculum, tuple is not going to show up for probably, if you're in a regular year-long course of Python, tuple doesn't show up, at least in my ecosystem, maybe until November, but I want to show it early. So the benefit is, of course, is if I've got a function, I have less parameters to keep up with. So if I don't have tuples, I've got to send the center, the X coordinate of the center and the Y coordinate of the center, and those namings get difficult. But by saying center, most kids can realize, oh, that's an ordered pair. And then, well, how do I access it? Ooh, my little square braces. Have we seen those before, children? Yes, we have. When we saw in the main event, we saw that it was using square braces to talk about arrays. So maybe a tuple is kind of like an array or a list, and it holds compartments. And the first one's in room 0 because people are crazy. They don't know how to count. And the other one's at room 1. So bringing in zero-based indexing. At any rate, we've got the draw head. So then we go ahead with our ghost, guinea pig ghost, and you can see I'm drawing the body, the feet, the colors, etc. Now, this is not object-based yet as such. And notice, if you're thinking about it, the head kind of sets the stage for everything. If I don't know where the head is, I don't know where the body needs to be. I don't know how wide the body needs to be. So when you look here where it says draw body, how did I do that without knowing where the head is? Well, there's a thread. Look at the thread. The thread that all of these things share is what? They're sharing the center. The center is the linchpin for everything. It's like my origin for the ghost, and the ghost's head is at the center of the ghost head. So if I know the center, which I do, I'm sending it to all the other little pieces. So this is getting them to see that these objects are interconnected. I can't have a disembodied body for a ghost. Well, maybe I can if I'm a real ghost, but not for a digital ghost. I've got to have the head and the body intertwined. Okay. Now, the eye is a little more complicated because the eye is dependent on the size of the head. So if you look at the eyes for a moment, the eyes are more complicated. And we actually had a lecture a couple hours long on doing the eyes, because notice, comments. Children, are comments important? Yeah, because they list our assumptions. So draw left eye. Well, I've got the head center, I've got the head radius, I've got my colors. Well, I'm going to assume that the eye span is 80% of the head diameter. Now, what I'll do is I'll have them actually get a piece of paper and a pencil, draw a picture. And I show them early on, you cannot survive this if you don't draw pictures. You cannot sit down with a computer, I can't, and just start coding without having drawn a picture laying out your geometry. So I said that the eye span is the distance from the left eye all the way over the left eye, the left side of the left eye, all the right to the right side of the right eye. That's the eye span. I assumed it's 80% of the head diameter. It's along the diameter. Then the eye distance, I just arbitrarily made 4% of my head center. And those are the assumptions that I'm making. So notice by knowing the head center and having some pre-assumed assumptions about the eye locations or the eye geometries, now I'm interweaving all that stuff to figure out the eyes. I'm using some fancy pants stuff with being able to go backwards, which makes it a little bit easier. Kids don't tend to think about being able to go backwards. So I can bring in the idea of the built-in modules of Tracy. The other thing I bring in a lot is I look at my docs and I say, okay, Tracy, what do you have? Well, Tracy has forward, backward, and they know this, but they might not use it. And the other thing I bring out to them as the former math teacher is that, do you mean we can have functions calling other functions? Oh, yes. And in math class, you didn't think that meant that was served any purpose at all other than to torture you. Remember when your math teacher would say things like y equal f of x? Yeah, we know that. What about y equal g of x? You mean I can feed a function to another function and compose them together? Yes, and that's what we're doing here. I've got my own function, draw left eye, that's calling functions from Tracy's world, which is backward, right, forward. So I have functions calling functions, which we really do want to be able to do. So anyway, you can go through the logic of this and also notice I've got little spaces here. I try to get the kids to realize often I will put comments there showing this is what I'm about to do. This is what I'm about to do. If I don't do that, at least put pockets of functionality. In fact, you might see I've done that elsewhere. I don't remember. I try to comment stuff and teach them good commenting. Didn't look like I did it here, but I guarantee I did it elsewhere. So the point of this particular lesson is I will show them code where kids were successful making at least one ghost, maybe more, with everything in the main event, without any organization, without any comments, without anything at all except Python-y Tracy statements, and without the ability of organization making any more of them as difficult. And so I, on the other hand, made one stinking ghost, a guinea pig ghost with goofball colors, made sure that was working. And then you all know what I'm going to do. I'm going to copy paste all the other ones, just change a few parameters. And because I'm using functions, before I know it, I've got the guinea pig ghost, the orange ghost, the purple ghost, the red ghost, the pink ghost. And then because Tracy's in the way, I wrote a little function to hide Tracy. Also, you'll notice, and you remember I was talking about breadcrumbs. I'm a big believer in breadcrumbs, and I will have shown probably the movie iRobot by then. And the whole theme of the movie is follow the breadcrumbs to solve the mystery. So I'll talk about the idea of showing breadcrumbs in the code and printing them out and actually showing sample output. What is it really calculating for the eye radius and the eye span? I don't have time to show this to you today. Time flies when you're being tortured. But you'll notice that I'm deliberately using fractional values because I want them to start seeing that not all the world is integer. And I want them also to start thinking about when they make their feet, which, where's that? Oh, do you think the mean old teacher would have them divide the width of the foot by the number of toes, knowing it's not going to go evenly, but it's going to truncate the answer, and then the ghost looks like he's handicapped because his feet don't go all the way to the end of his body? Do you think there would be a mean teacher in the world that would do that? Yes. What's happening? The feet are messed up. Google, ask the right question. So I teach them, division. And Lori, it just wouldn't be a seminar if I didn't tell them about this. So I'll put in a comment, hashtag DWR, division is evil. And those of you that may have been around before and lived to tell about it, DWR is my little signal that it's a danger Will Robinson moment. And yes, I know I'm showing my age, but if you remember the old 60s Lost in Space, the robot, danger, Will Robinson, danger. I use that to showcase evils that may befall us. And in case you think I'm really dated, Netflix has come out with a reboot of Lost in Space, which is really good. You ought to see it. Don, I hope you've seen that. I'll be disappointed in you if you haven't seen that.
I was just going to say, they redid it, man. They redid it.
They did a good job. And so they still have, I was going to be really disappointed if they did danger, Will Robinson. And they did on the first episode. It made me so happy. So anyway, I will have them mark pockets of danger in their code. They're so tired of me saying, danger, Will Robinson, danger. But I want them to see early on about truncation and why that might happen. So anyway, I'll let you look at the ghost of a chance. You can see I've organized it in pockets, but let's move on and look at the next stage of evolution. So in the next stage of evolution, it would be 2 here. I seen a ghost, okay? So in this stage of evolution, which is finished, but not complete in the whole evolution, when I run, you can see in this case, I do have a ghost because, and the ghost has eyes. Oh, and by the way, I said I was going to do that other, but my little thing is in the way. Let me just do this. As we have what I call morals to the story, I will summarize stuff in the comments. This is another usage of the header comments. So I'll put in, what have we learned here? And so I'll come in and say all this stuff. One thing I will point out, if you're new to Tracy, one of the things that's a big problem, especially in a more complicated project like that, is Tracy needs to know her direction as she starts new stages of motion. And if you're not careful to put Tracy back to a way that she knows, which in this case is east facing, things go really crazy. So in fact, I've got several scouts in my classes many times, and there's a Boy Scouting thing called Leave No Trace. And I adapted it, leave no Tracy, leave no Tracy, meaning we put Tracy back to an east facing position to make sure we don't go nuts. So the point here is that if we don't take care of the main event and let them put their feet up on the desk and just direct other work, they're tired. We want others to do the work. And also, here's where I made the comment about all the ghosts were looking the same way. Could we randomize people locations? So that's why I went into this new stage of I've seen a ghost. And so what's going on here is the eye development in a little bit more detail of how could we bring in the directionality of the pupils. But I will just mention here, if you're on your toes, in the previous versions, you were probably horrified to learn that I had a draw left eye function and a draw right eye function. And you should have been breaking in hives thinking, that's stupid. If you can just draw an eye, it doesn't matter. You just provide the right parameter to stick it in the right place, shouldn't you? I'm glad you said that, because in this stage of development, we talk about the idea that we don't need 2 stinking functions to make eyes. We need one, draw an eye, and look what I provided. We love you functions. I provided an offset. The offset says, which direction will I go, to the left or the right, to draw my eye? So with one little baby parameter, I've negated the need for 2 functions. I've got it down to 1. And where my mind is going is, wait till you ain't seen nothing. Yeah, wait till we get to an object for the eye, but that's coming. So also you'll notice one little thing here. If you were a meanie, if you look at the code here carefully, see how I've been bitten so bad where teachers, but students love to throw me under the bus. Have you had that happen to you? Mr. Pendleton, if you don't give the right offset, the program crashes. Yes, I know. I've been around the block a few times, so I know that you're going to say, well, what if we have the eye offset go up or down? The program crashes. Well, no. If offset isn't equal to left, and it's not equal to right, I'm just going to return. I'm not going to draw eyes. The ghost will be blind. Sorry. So I try to anticipate evil things that could happen. And while I'm at it here, on the feet thing also, you might have noticed what happens if they give me a height that's less than the radius of the head, that can have the geometry can go nuts. So I have some logic here that says, all right, if you're going to be mean to me, if you give me too short of a ghost where the body's going to be inside the head, that's awkward. I'm going to set the radius to be, I'm going to set the height equal to the radius. What if you try to give me, and I do this, I mean, if I had $1 for every time students did this, I could retire. As a teacher, I'm probably never going to retire. I gave it 5,000 feet and the program crashed. Really? You're going to give it 5,000 feet? Really? Well, I'll fix you. If n is less than 0, n is 0. If n is bigger than 8, let n be 8. If n equals 0, why draw feet at all? Return. So I try to have safety nets, and I teach them this. Usually, I'll let them have their fun. I made a ghost with 15,000 feet. It broke. How can we prevent that from happening? Okay, so there we go. But you can study here that I took the dual I code and made it into one, but I still have residual code here. Oh, but I did introduce something else. I have a draw eyes function. So the draw eyes function looks at the directions and uses the idea of offset. I can draw a left eye and a right eye. So I traded out one function for another, and I'll let you study this a little bit. Let's see if we can get into more of the objecty stuff. So now I go to option 3, head, body, toes. So, and if they're really mean to me, I will sing the song head and body, knees and toes, just to wake them up. But then I remind them our ghosts don't have knees, but head and body and toes. All right. So what's going on here? Well, this is the advent of the class. You've all been waiting for this now. We've talked them through doing things where the main event's doing everything. Okay. Then we start chopping things into functions. Okay. We can use parameters to tweak duplication of code. Okay. But we've learned that the ghost, everything hinges on the head. So if I could make the head of the ghost independently as an object, I could then use a manufacturing process to get everybody else once the head is created. So now I've kind of gone on a warp drive here. We've gone from one thing that's a little shaky. Now you're like, oh my gosh, my eyes are about to explode. You're going into classes, yes, but I'm assuming that you've seen this maybe in one way or another. So I have kind of gone into a warp drive here a bit, but let's look and see. Let's first look. I teach them that if you've got some code and you want to know what's going on, go to the main event. Remember, the main event is nothing more than the orchestration of some events. So if you're disoriented and looking at code, and who isn't? Because think about it, they're smart. They're going to go to internet and they're going to look up, how do I do so and so and so and so? And they're going to see a horrifying amount of stuff. And so ultimately, you want to hopefully find, where's the big idea that shows me how the parts are connected? Oh, main event. So I've got a center, I've got a head radius, I've got a height, I've got some eye colors, and I've now, oh, look, this is new. I used to have a draw head function, but now I have a different function. It's the head function coming from a class that takes the same ingredients and makes a head, and then the head knows how to draw itself. And they might be horrified at this. But I said, but wait, didn't we just write a function that knows how to draw a head? Mm-hmm. Couldn't we encapsulate that into a factory that makes heads for a living? I guess we could. Well, to do that, we're going to go up to the head class. There it is. Head class colon. Oh, look, he marked it in head class. Well, I told you that the head function was really a function, but it's a special function. Yes, it's a function in the class called the dunder init method. And it's a specialized function, DEF, whose job is to initialize all the things that make a head. Didn't we say earlier that a head has a center, and that a head has a radius, and that a head has a color? Yes. Well, why don't we send them to the init function and just say, hey, I'm thinking about a scenario where the head's self-identity, think of the Easter egg, I've just put a center in that Easter egg. That's what self means. I'm encapsulating a piece of information called the center into the self of the head, and likewise the radius, and likewise the color. And that's all dunder init's doing, is it's setting up an Easter egg shell with those parts. Now, heads know how to draw themselves. So I've got a member function. Oh, but wait, did I tell you that a function inside a class is called a method? Oh, I forgot to tell you that it is. A function in a class is called a method. So we've already developed this. So couldn't we just copy paste our code for drawing and put it in here? We could. Oh, but wait, we have to tie everything to the self of the object. So rather than just saying center 0, center 1, we've got to say the self's property. And in fact, the draw function needs to know which self are you talking about. Are you talking about the yellow Easter egg? Are you talking about the blue Easter egg? Oh, I'm talking about the yellow one. Okay. Well, it knows its own self properties. And at that point, I will get out several Easter eggs. Here's the yellow head. Here's the blue head. Here's the pink head. Crack open the egg. We're sticking in your values of radius for this one and its colors and its center. And in fact, I'll even have a smaller Easter egg where I take bits of paper. This is the tuple for the X and the Y. That's a smaller Easter egg. It's an object being put in another object. So hopefully they walk away knowing, oh, okay, this looks so foreign, but it makes sense to me that it's a manufacturing plant for heads. And then could we do the same thing and make a body? And there I even say a self serves as a plastic Easter egg that encapsulates all the properties of a body, its location, its radius, its head, and its color. And you might be troubled a little bit by looking at this, because when you come down and you look at the driver code, remember, if you get confused, go to the driver code. It shows you the overall idea. Well, I drew a head, I made a head, I drew a head. I made a body, I drew a body. But that body still doesn't know about that head, right? Although they're tied together through the center. But this is baby steps, right? I started with the main event doing everything. Then I made functions that the main event called. Then I made a class that encapsulating certain functions. But those objects, head, body, feet, are still disembodied. So you know what the next stage of development might be? Wouldn't we want to put all of those in a ghost manufacturing plant? And yes, children, that's what we do. So now I actually, oftentimes, this is a valuable tool for me. I call it code vandalism. Code vandalism says you take something that works and then you deliberately break it. And the kids love that. And then you look at the error messages. What happened when I deliberately made this problem? Oh, so I evidently created a variable that I deliberately didn't identify called toe radius. And poor little Tracy snarled at me, if turtles can snarl. And attribute error. Okay, line 226. So we go to the scene of the crime. And so I'll often show that. So the next stage of development here, I can draw feet, I can draw heads, I can draw bodies, but they're all not connected. Now, by the way, I'm horrified to see we've only got 15 minutes left. Lori will kill me if I don't give her some time left. But you could go through and look at the comments, because these are comments that come up in our discussions in class. And I try to summarize what we do and what's happened. But if I go to the next stage of evolution, that was 3. So the next stage of assembly required. This is like going to IKEA. This is the IKEA phase. Have you ever been to IKEA and got something that looks so great on the showroom, and then you get home and you think this is going to take a week to put it together? This is the IKEA phase. Because what I'm doing is I've got my ghost. Don't give up the ghost. I've got my ghost. Oh my gosh. I got to take all that junk and port it over here. Some assembly required. It's not going to work right out of the box. But I do notice something about my ghost in it. My ghost in it is making the head. My ghost in it is making the body, because I can't have a head and a body without knowing where the ghost is. So if you were worried about the fact that in the main event earlier, I was making the head and the body independently, now you should be happy because the ghost factory is making the head. Look at this. The init method, I'm saying, Mr. Ghost, you're going to have a location, a radius, a height, a number of feet, eye data, and a color. That's all we need. I already proved to them that it worked in the driver code from the very beginning when I showed them the main event. And so Mr. Ghost is going to have a location, a radius, a height, a number of feet, eye data, a color, and self.head is a head. It's a call to the head. Dare I say it? The head constructor and the body constructor. Do I use Java parlance in the Python world? Yes, it's terrible. Should be shocked, but I want them to know that. Anyway, so now the ghost draws itself by, oh, magical. It's supernatural. Look, the ghost knows how to draw itself, but the head knows how to draw itself. The ghost doesn't care. The body does that work. The head does that work. This is OOP. This is object-oriented programming. OOP. Everybody knows how to do their own thing, and they just work together nicely in the sandbox. And that's my end game, object-oriented programming. So, and there we've got our head class. There's our body class. There's got our feet class. There's some hanging around function. Now, you might think, why do you have all that there? For reference, some assembly required. I had to copy, paste, and change some things around. And I'll let you study that. But if I go and look, that was 4, 5, a sight to the blind. Okay. Sight to the blind was getting the pupil stuff to work. Because if you may have noticed that I didn't in that thing have the I class. The I class actually was a little harder because now you got to worry about the position of the pupils. So if we only had what we had before, did I run it? It's terrible. Mr. Pendleton, you had code and you never ran it? We got a blind ghost there. Oh my gosh, where's the ghost? Well, I see him. This is IKEA. Parts were missing. Darn it. Sight to the blind. Let's bring in the eyes. Oh, and look. A trail of breadcrumbs. I can be taught. Sight to the blind. Eye data is this. Can I have a nested set of lists? And you will get so excited about this. I didn't know if it worked. Non-homogeneous multiple dimension list. Because I gave the stinking thing an array of strings and an array of numbers. I didn't know if I could get away with it, but I did. And so I'm making a ghost, constructing a ghost. Now look at the little breadcrumbs, constructing a ghost. Oh, I'm a ghost. I'm getting a head, I'm getting a body, I'm getting feet, I'm getting an eye, I'm getting an eye. It all works and is proof, a goofball ghost. And then version 6, what possessed you? What goes around comes around. This is what we saw at first. Look at it. When in doubt, go to the main event. There it is. This is what I put in the PowerPoint. That's the outline. The main event is lazy. That person just wants to point and say, do this, do this, do this, do this. I'll drink my coffee. We'll let the ghost do the ghost work, but the ghost will call the body and the body will do the body work. And then the head, I won't do that. I would sing it in class. They really do worry about me. Let's see. So that's the code that you saw in the PowerPoint. Now let's see. Oh, I must say, Java teacher in me says, can I make a copy constructor of a ghost in Python? And so Stack Overflow questions, copy constructor in Python. Oh, this was so sad. Non-implemented error. Copy is not yet implemented in Sculpt on line 193. In other words, doesn't support copy constructors in this environment. I'm so sad, but anyway. Well, if you've survived this far, that means you're really something, especially when you didn't have to be here. You could be on the beach and instead you're learning about Python. Bless you, bless you. Lori, that's it. They're probably have fried minds. And if I don't stop, I'll probably go till 3. Everybody would like it if I went till 3. But thank you guys so much. Y'all are an enduring audience, I must say. If there's anybody left, I'm looking. I can't see if anybody's left, but thank you very much.
Just so you know, one of the really cool things about your workshops is I always watch that number of attendees, and it'll fluctuate often in workshops. People have other things, and it is consistent with yours. People don't leave. I've had people tell me in the past that they've had something they had to go do and they changed their plans because they didn't want to leave. So
very nice. There's a lot of crazy people in this world. I should know.
So I'm gonna. Go ahead. Yes,
we had a question come in that I think is probably best for Kent to answer.
Okay,
cool.
We had someone ask if they could get a little more detail about how the draw self function works between the different classes that they were following, and are maybe about 80% on that week.
That I appreciate that so much. Whoever asked, yes, and I realize I'm soft pedaling that a lot. Lori, would you like me to try to answer it?
Please do, go for it.
Lori, I know that you've got things you needed to say too.
Well, here's what we're going to do. So Kent, I'm just going to put some of those other resources in the course. So that way y'all can see that if you need some help with it. And you've always got us to ask if you need help with sandbox, forking, any of that stuff. And then we'll actually, Kent, once you start wrapping up that question, we'll just share I'll throw it back to me and I'll share out the last few little things. Okay. Perfect.
And Lori, you can still see my screen, right?
I can. Perfect.
Okay. So that's a brilliant question. That's the kind of question that tells me someone's thinking, and I will have that similar question in my classes. And so I'm in the stage 6. So this is the end game. Let me see if I can answer that question from the end game. Keep in mind that when we did any drawing earlier on, I always go back to first principles. When they did their ghostly challenge 1 hour, they were using Tracy just to draw Tracy go left, Tracy turn, or Tracy go move forward, Tracy move right, go down, turn back right, draw a circle, go back to the radius. And so kids have probably practiced that a little bit and they feel okay about it. Ultimately, what I'm doing is I'm just shoehorning that functionality into pockets. So for example, if I were to look at the head class only, because I haven't put all this in a module. I didn't want to terrify people like that. It's all in the same source code. But so if I look at the head, if a student asked me that in class, I'd say, okay, let's go back to the very first problem and let's find where you drew a head for your ghost. And I might even use their code. And so I'll say, so what did you do when you drew that ghost? Well, I had a center, and then they'll walk me through the recipe of making that ghost. And I'll say, you feel good about that, don't you? Yes, I do. Okay, so all we've done with the head is that we've created a class that kind of puts the properties of a class head along with its drawing functionality. In other words, we're putting a plastic Easter egg that encapsulates all the information or data about a head, along with how to draw itself. So when I created the head, I created this init method, and that says, here's my raw ingredients, and these are now properties that all the other people in this class can use. Now, my draw method is different than say the circle method that Tracy was doing. When I did Tracy doesn't have a draw method as such. She has a left and a right and a backward and a forward and all that stuff. What I'm doing is I'm encapsulating those functions inside a function I wrote called draw. I could have called it sketch. The name is immaterial, but it should be self-documenting. And so by saying for the head, def draw self, in English, this is saying, all right, I have a function called draw. I could have called it, eat lasagna, but it's drawing. Okay. This parameter self is genius. Remember, if I write a function, I have to give all the ingredients for that function to do its job normally. But what if I'm lazy? I don't want to give the radius separately and the color separately and the location separately. If I provide the self, think of the self. I should have brought my Easter egg. I'm in somebody else's office today. Should have brought my little Easter egg prop. But the self encapsulates everything about the head at the moment. So draw needs ingredients. What are the ingredients? The head's self. What does that self have? A center, a radius, and a color. So if you think about that thing where I said some assembly required, I'm having to shift things around a little bit. In my earliest of drawing circles, I was using only Tracy commands. But now I put it in a function, but now that function's calling a parameter, and that parameter holds all the information about center and radius and color. That's why I have to have here draw self, because that's holding these, what are called IVARs or instance variables or attributes. This self is the Easter egg. Think of a little Easter egg right there. So then when I go self position, that's cracking the Easter egg open and getting its center, and then that's grabbing the X coordinate of the center. That's cracking the egg open and getting the center tuple and getting the Y coordinate. This is cracking the Easter egg opening and getting the radius. So I'd actually have my Easter egg there. Now y'all going to go to Walmart and try to buy Easter eggs, and you're going to be mad because they don't sell Easter eggs now. Dang it. But so anyway, self.radius is going to be the property from the self, the Easter egg that's got the radius property. So insightful questioner. I don't know who asked that question. This is nothing more for the head than I did earlier, except I put it in a function called draw. I'm not providing 3 parameters. I'm providing 1 that are coming from properties of the head. And now I'm just saying, Tracy, move forward from the self's radius and all that stuff. So the only thing that's really changed in all these is a prefix of the word self. Now, to answer the next question, when I go to the ghost, that was such a genius question. When I go to the ghost manufactures the head. And now the ghost has a head attribute that was generated by the head factory. So now when I come time to draw the ghost, I don't have to have the ghost do all the brain work for drawing the head, because the self Easter egg of the ghost has an embedded Easter egg called the head, and the head knows how to draw itself. And likewise, the body knows how to draw itself. So what's happening magically is when you see this right here, think of a blue giant Easter egg holding a yellow giant Easter egg. And when I open up that Easter egg, there's a draw function that's affiliated with the yellow Easter egg that was in the blue. The blue big Easter egg has a purple Easter egg. And that purple Easter egg has a method inside it called draw. But that draw is affiliated with that body. That draw is affiliated with that head. They all know how to do their own thing. And they've all got their own individual draw methods. And I could have, on one level, I could have made them different names But on the other level, I deliberately kept them the same name because I want people to see that's the magic of object-oriented programming. I'm just going around crazy looking for the code. There's the draw. So by calling it all draw, I'm being kind of consistent. I'm saying if I want something to show on the screen, it's always going to be a draw method, but the draw method may be affiliated with one object versus affiliated with another object. So it is a little confusing at first, but if I had you in class, I would have my Easter eggs nested. This is the ghost. Here's the yellow Easter egg inside the big blue one. That's the head. Let's crack it open. Oh, it's got a draw method. Okay, close that back up. We drew its head. Now it's got a body. That's the yellow, that's the orange Easter egg inside the big blue Easter egg. Let's crack it open. Oh, it's got a draw method. And those individual draw methods are using their own self properties to draw themselves. And I must say, often, beginning in Java teacher, I'll say, you'll see this when we get to Java. You'll see this when we get to Java. And they look, he's stuck again. Oh, in Java, we have the same idea. It's not called self, it's called this. It's a self-referential to an object. And Lori, it's 1 o'clock. It's dangerous asking me questions, MR. Dangerous, dangerous, dangerous. Danger Will Robinson asking him a question. Okay.
I'm just the messenger.
Okay, you're just a messenger. Okay.
Danger, Kent Pendleton.
Yeah, danger, Kent Pendleton. Right.
Dangerous, but so educational. So we love it. All right. Definitely hope that helped. And that was an awesome question.
It was an
So that
awesome
was
question.
great. So I'm going to steal the share for a moment
Okay.
and just share a couple more resources with everybody.
Can I
And
stop share, Lori? Okay, you did it.
I can totally steal it.
You have
So-
superpowers. I forgot.
superpowers. All right. So a few more resources for you. And Don just threw in a whole bunch of them into chat. So a few things we wanted to share first, and we've got all these links on this slide, so you can get to them here too. First of all, if you have not joined our CodeHS community Slack workspace, we definitely invite you to do that. This is a cool Slack workspace that we're just starting to build up and get more and more computer science educators in it. So go ahead and join that. We actually have a few channels started there. So if you want to join the Python channel, you can. And I haven't even told teacher trainers that we have those channels. So just saying, Kent. But we have that. We've got APCSA, APCSP, a bunch of channels. So definitely join that and we can help shuffle you around if you like. And what else? Oh, we have more workshops coming up. Next week, we kick off the week with Teaching Intro to JavaScript for Experienced Teachers. That one is going to be led by teacher trainer Joe Thompson. I definitely invite you to register for that one. Then on Wednesday, we have Teaching APCS Principles with teacher trainer Brandy Johnson. And so absolutely head on into that one as well. And the one that got left off of this slide for next week on Thursday is Teaching Web Design with ours truly, Ken Pendleton.
I wonder why you let that off, Lori. You're protecting you're protecting
Oh, no.
your labor.
I should have made a slide all for just yours.
We know
but
why she left it off.
definitely register for Ken's workshop. It's going to be really cool. I am very, very excited about his web design workshop. So head out to codehs.com/freepd to sign up for those. One more link, codehs.com/workshop survey. Please let us know how we did. Let us know if there's anything we can do differently or anything you'd like to see from us. Anything that you'd like to see specifically from Kent. Go ahead and let us know that too. But take some time to fill that out. We appreciate that very, very much. And I'm going to say just a few quick thank yous. First of all, thank you, Kent. This was amazing. And it felt like about 5 minutes long because it was this much fun. I was absolutely having a blast with this. So thank you, thank you, thank you. Very excited you're going to be back with us next week again. I cannot wait. And thank you, CodeHS team. Thanks for getting those links, taking care of all that support. I so appreciate everything you've done too. And thank you, teachers. Thank you, teachers. We appreciate everything you do for your kids all year long. And thank you for taking time out of your summer break. And hopefully you're on summer break. Hopefully not too many of you are doing summer school or maybe heading back to school. Who knows? But thank you for spending that time with us today. We appreciate you, and we are here to support you. So thank you very, very much. And with that, I'm going to go ahead and wrap up this workshop and say, can't wait to see you all again at the very next CodeHS workshop. See y'all later.